I'll be talking about what we can expect with Compose, what we can ask for in terms of our developer experience, and also share some helpful explanations, notes, and tips to help you along the way with the journey on learning and applying Compose. So first of all, Compose is a declarative UI framework. So as you've seen from Kurt's session, it is very different from how we are doing things previously. So instead of having a bunch of view objects and manually managing the state of these views, such as, for example, updating the background color, setting it to disabled, changing the visibility, or adding or removing child views, in Compose, we write code that describes how our UI should look like. So what does that mean? So if you're like me who prefer simple words instead of fancy terms, a simpler way to describe is that declarative UI means that our code is our UI. So let's take a look at a very simple example. So here we have this very complex and beautifully designed layout of a screen in our app. So I recruited the best designer that I can find to provide me with this mock. So in case it's too sophisticated, this is actually the profile screen. And on the left is the logout state where we display the app icon and the login button. And on the right, when we are logging, it hides the login button and display the message, a greeting message for our user. So in order to implement this complex UI with the current view system that we have to create a linear layout containing a text view for the greeting message, the image view for the app icon, and a button for the login button. And depending on whether the user object is now or not, we'll update the visibility of each view and also update the text of the greeting text view if the user is not now. So this means that we are going to have all these view objects together, and then we have to update the state of these view objects to reflect the current application state that we are in. So I'm sure that the actual apps that we have is going to be a lot more complex than this. And as it grows in complexity, it's also easier to make a mistake where we don't reflect the app state accurately, such as missing out the update to some views here and there, and we'll end up in some inconsistent state, such as forgetting to hide the login button when we are already logged in. So on the other hand, with Compose, we only need to describe how the UI should look like by invoking composable functions. So we don't have to manipulate the view objects. We can even use control flows such as if-else to decide what to display and what not to display. So if we can use control flows like if-else, then it naturally follows that we can also use things like for loops as well. So in case I want to display a text multiple times, I don't have to create multiple different text views. I can just use a repeat, or we can use for loops, while loops, for each, and things like that. And also, as a more realistic example, declarative UI also makes it very easy to build UIs that requires a lot of different classes, such as list. So if we want to use, in our app, if we want to have, let's say, display a list of users, like in this code here, we can use the lazy column composable function, which Kurt has talked about just now. And this behaves like the recycle view. And we are only, and it provides this, we only have to pass in this list of users, and we can show a list of user composable, user role composable, and that's all is needed for us in the Compose world. So if, let's say, we want to support multiple view types, we can simply use an if-else statement or when statement. So we can just say if the user role is admin, I'll show the admin role. If not, I'll show the normal user role. And if we want to add a divider for each item, we can just wrap it in a column and add a divider at the end, and we will just have a divider at the end. And if I want to add some spacing to each item, for example, I can just use the padding modifier and use the modifier to add some spacing. And now each of our list item has spacing. So in the end, we noticed that when we slowly build our list UI with more and more features, we are actually using just very simple code all in a single place. We no longer have to jump through hoops and use all the different classes to achieve the effect that we want. So things like recycle view, list adapters, difutil, payloads, you know the rest, right? So we don't have to use them anymore. And this just shows how declarative UI can really simplify the way that we create UI in our apps. So this leads us to the next question. if we are building UI with just composable functions, do we still have the need for activities and fragments? Right now, in the current Android world, we may be debating about whether to use multiple activities or follow a single activity architecture, and whether we should use fragments, or if fragments are evil and we should avoid them at all costs, right? However, there really isn't much reason for us to be talking about activities and fragments. Fragments was introduced initially to provide us modularity and giving us a way to split our apps UI into separate logical chunks of code. So I believe many of us have been using fragments to build our screens, and now that can be replaced with a big composable functions made up of smaller composable functions. So for activities, they can be replaced by fragments as per the single activity architecture, which then can be replaced by composable functions. So with compose, since everything can be written as a composable functions from a small UI element such as a button to entire screens, multiple activities and fragments can be a thing of the past. Well, not entirely. So technically, we still need an activity to host our UI, but the activity can be super simple like this. So with the set content function, we are able to invoke a composable function, and that composable function can be the entry point to our entire application. And then you might be wondering how to achieve certain things that we did with activities and fragments, such as navigation. For that, we can actually manage our own navigation state in composable functions if the app is simple enough. Or we can use libraries such as Jetpack Navigation, or even libraries contributed by the community like Compose Router. So for dialogues, we actually need a window, not activities and fragments, and Compose has built-in support for that. So for methods that we use to override inactivity or fragments, such as backpress, we can use the back handler, which make use of the onBackPress dispatcher. There's a composable function for remember launcher for activity results, which make use of the activity result registry, so we don't have to override the onActivity result method. So the Android X APIs were already evolving to reduce the needs to override methods in an activity. And now with Compose, virtually anything that you previously need an activity for, there's a solution for it as a composable function. So if you're already tempted to try out Compose but are worried about how to introduce it to your app, the good news is that it's very possible to do it gradually and without having to overhaul your entire code base. It is possible to mix and match traditional views and Compose together with Compose View. Here we see that in our XML layout, we can add a Compose view in the layout itself. So it acts as a host or a container for our UI built with composable functions. So we can get the reference to the Compose view and set content and call set content to it. And inside set content, we are able to call our composable functions. This allows us to first build small UI components in Compose and then use it together with our existing views and layouts that we have. So doing it the other way around is also possible, where we can include traditional views in our composable functions. So in this piece of code, we can see that we can instantiate a view and we can set click listeners to it and even interact with state in the composable function. So the view can also read and be updated of composable state in the compose function. So using this approach, you are able to still use UI components that are still not yet available in Compose, such as a map view, for example, or some complicated custom views that you already implemented previously and you don't want to re-implement it in Compose. So you can use this to mix and match your views. So if you're already heavily invested with the current XML theming, and you are using the material team, the material components team also provided a Compose theme adapter. So this allows us to reuse the theme that we have defined in the XML as a theme in the Compose world. So we can share theme attributes such as color primary, and we can be sure that they are consistent between our existing UI and the new UI built with Compose. So the strategy for migration can generally be first to implement small components such as buttons, cards, list item, and dialogues. And after you got the small components implemented, you can begin and you start to begin to understand more about the concepts in Compose, and you feel more comfortable working with Compose. We can move on to bigger things like layouts, using the small components as our building blocks to build one whole screen, until the entire UI of existing fragment or activity can be rendered as a composable function. And the last step will then be to replace these activities and fragments with just the composable function itself across the whole app. So it's good that we have now decided to adopt Compose. So let's talk about one cool thing that comes with it, and that's how Compose is able to handle configuration changes seamlessly. So before Compose, if we want to do things differently based on the configuration of the device, so we'll have to define separate XML files and allow the activity to recreate for changes to take effect when configuration changes, or we have to override on configuration change to handle the changes manually. However, with Compose, every time the configuration has changed and is updated, and if we are reading the configuration through local configuration.current, a recomposition will be triggered and the composable function will run again and update our UI automatically. So for example, here we can read the orientation of the device through the configuration provided by local configuration, and this will update our UI automatically whenever the device is rotated. So we can also use React. We can also react to configuration changes, not just for layouts, but also for values. So we can use the screen width of the configuration to determine the number of columns for our grid view, for example. And if the user resize the app or do anything which changes the width of the window of the app, the number of columns can be updated automatically when recomposition happens. Reacting to configuration change also applies to locale as well. So this is obviously useful for string resources. And if the user changed the device language, for example, when using the app, Compose can automatically react to that and trigger a recomposition and display the strings in the correct language. So what all this means is that we don't need our activities to be recreated in order to have the correct UI anymore. So when we are starting out in our Android development journey, I'm sure we have encountered this infamous issue where our app doesn't work after a orientation change. And then after Googling for some Stack Overflow answers, they just tell us to add this config changes equals orientation to fix all our activity problems. So that's definitely not the correct solution then, which is why we have many Jetpack libraries such as the architecture components, live data, and view model to solve this problem. However, now with Compose, this is no longer a problem, and we can safely add the config change to our activity in the manifest. In fact, we should be doing this. Compose is able to handle all the configuration changes, and there's no reason for our activity to be recreated. This is the full list of config change that we can apply to our activity to prevent activity recreation. Activity recreation can be relatively expensive, so avoiding it can probably result in a better user experience. So when we talk about reacting to configuration change and avoiding recreation, you might be also wondering how Compose has changed how we handle life cycles in our apps. So just to give you a reminder on the current state that we have with activities and fragments, this is the life cycle diagrams for activities and fragments. And I think everyone memorized this when starting out as a junior and going for interviews for an Android role. So and this is the complete diagram of how a fragment lifecycle can be inside an activity. So we have to handle cases such as fragments being attached or detached, and a separate lifecycle just for the views in the fragments, and worry about memory leaks. I think this is too small for you to see, but I think it's okay. I'm just showing you to give you some nightmares, huh? So as a contrast, this is the lifecycle diagram of a composable function. So for a composable function, it starts when it enters the composition. It will recompose n number of times, and it will end when leaving the composition, and that's it. So we talk about configuration changes, and we have seen how the lifecycle of a compose function is so much simpler. You may then be curious to know if the existing solutions that we engineered to handle the complex lifecycle, such as view model, whether they are still required in the compose world. The primary reason for view model is to ensure that our data survives configuration changes and across recreations of our activities and fragments until the on-destroy is caught. However, with compose, because of the much simplified lifecycle, it seems that view model may not be needed anymore. We just need a class. We don't have to extend the view model class. And that's probably going to be true for most of our use case. So our UI or our screen is going to be a composable function, and we just need a class without extending the view model architecture component view model. So I'll just use presenter here as to remove any ambiguity, and we only need a single instance for it to load our data and handle user interactions. we can easily achieve that with remember. So here we see that we can use remember to persist a single instance of our presenter throughout our lifecycle of the composable function. Without remember, the code will actually run for each composition of the function and create a new instance every time. So just like how we persist a view model through recreations until on destroy, here, if we use remember, we can guarantee that we have the same instance from the start to the end of the composable. So remember can also be used for any arbitrary classes or state or data that you have. So it is also typically used to remember objects or calculations which are expensive to create or compute. So if you want to be notified of when the composable is leaving the composition, which is when the composition lifecycle ends, just like the on destroy, we can use disposable effect. So on dispose will run whenever the composable leaves the composition or whenever the key pass to disposable effect changes. So it's the perfect place for cleaning things up or releasing resources to avoid memory leaks. So one gotcha about the composition lifecycle is, which may not be obvious, is figuring out when a composable actually enters or leaves the composition. So for example, here on the left, we have two different composables. So one is the UI for email login and another for social login. So for the email login, we have a text field, and then for users to input their email address. And for the social login, we'll just show the different login buttons. So on the right is our main login screen. So there's a button to toggle between the email login or the social login. So if the user click on the button, is email login will change and the screen will be recomposed to show the different login composable. So here we start with is email login equals to true, and then we show the email login composable first. So now the user happily types in the email address and accidentally press the button to toggle to social login. So now is email login becomes false and the login screen gets recomposed, and now we are showing the social login with the buttons. So the user press the button again to toggle back to the email login, and then finds out that the email address that was typed in previously is now gone. So why is that? So that's because when is email login turns from true to false, and when the if statement goes to the else case to show the social composable, the email login composable actually leaves the composition. So it is at that time where the composable lifecycle ends. So when we toggle back to the email login again, it will be like a new instance of the composable. So it is a fresh, you'll start from the start of the life cycle again, and any previous state that is remembered will be gone. So if we want some of the state to survive longer than the life cycle of the composable, we can usually hoist it up to the parent composable. So instead of remembering the email state at the email login composable, we move it up so that it sits in the parent composable, which is the login screen. So this is generally a good practice in Compose, where we keep our composable stateless, and we are able to better control the lifetime and the scope of our state and our data. So there's another variant of remember called the remember savable, and this acts like the on save instance state and the on restore instance state that we have in our activities and fragments. So your data not only survive across recompositions, but you also survive process death. So of course, similar to remember, the data will be forgotten once the composable leaves the composition. So the rule for saving instance state here also applies for remember savable. So regarding the type of the data that can be saved. So we can only save primitives such as strings and floats, and also parcelable data. So of course, you can also choose to save a custom data type, but then you will have to provide a custom saver, which will serialize your custom data type to the allowed data type, which are the primitives and parcelables. So let's move on. Adopting to Jetpack Compose, it is probably a good time to start looking into Coroutines and Flow if you haven't already. So many Android X libraries are now having first-class support for Coroutines, and Compose is obviously not an exception. So there are many APIs and features in Compose which makes use of coroutines, and there's also API which makes it easy to collect data from a flow. So just as activities and fragments have a lifecycle scope, it is also convenient to get a coroutine scope tied to the lifecycle of the composable with remember coroutine scope. So this is useful for launching a coroutine outside of a composable, such as in a button callback. So all launch coroutines from the coroutine scope will also be automatically be cancelled when the composable function leaves the composition. So we don't have to worry about manually cancelling the job. So here we have a button where when you click on it, it will show a snack bar. The show snack bar function is a suspending function, and therefore we have to launch it in a coroutine to call it. And we can use the scope from remember coroutine scope. So using suspending functions for the APIs can be very powerful, especially when modeling things that can happen over time. So when we call the function show snack bar, it will suspend until it is dismissed or interacted on. So with suspending functions, there's no need to register for action callbacks or a dismiss callback. We just wait for the suspending function to complete. And this will allow us to write imperative looking code, which you can see here. So many Jetpack Compose animation APIs are also available as composable functions such as animated visibility, and they are all backed by lower level APIs built with coroutine suspending functions. So if you want to be building and customizing delightful animations into your app, it's good to familiarize with suspending APIs that the animation APIs provide. So in Compose, it is also very easy to collect from a flow with the collect as state. So what this does is that you'll transform the flow into a composable state, which you can read from composable functions. So in case the flow is a hot flow, and we will be wasting resource if the host activity is in the background. So when the app is in the background, the composition will be still active and the collection of the flow will never stop. So which means that the flow will still continue running and producing values. So in the newer versions of the Lifecycle library, I think version 2.4, an extension function is introduced to allow collection of flow following the lifecycle of the lifecycle owner, which is usually the host activity. So this makes it more like live data, which is built to be lifecycle aware, and which will automatically start or stop collecting from the flow depending on the life cycle of the activity. So the Android DevRel team has also published this article talking more in depth about this and why it is important. So be sure to check it out. Next, I'll be talking about Jetpack Libraries. So they have served us well and has been very useful to us to help us in writing our apps. And I cannot imagine being an Android developer without these libraries. So some of them may become less relevant as we move to Compose, especially for the view-related libraries and things such as app compat or live data. But they are still, but some are still very useful, and it provides us with the Google recommended approach of writing apps in Compose. So let's take a look at some of them. So I think the navigation component is one of the most useful libraries that we can use in Compose. It helps us to manage our navigation graph and organize our screens. So it is actually the exact same navigation component as the non-compose variant, just with extensions to make it work with composable functions. So this is for Compose. Obviously, we will not be using XMLs to build our navigation graph, and for now we won't have the ability to preview our navigation graph. Instead, we'll be using the Kotlin DSL to build this graph. So the nav host is a composable function, and inside it, we can declare routes for the different screens that we have. So routes are like URLs. So we can make use of this to pass data to our screen by appending query params for optional arguments, or making the data part of the route for non-optional arguments. So for example, here we have the home route without any parameters, and the profile route takes in an ID in the path. So because this is a string, right? So the one restriction here that we have is that we can only pass simple data types that can be encoded as part of the route. And we cannot be passing parcelable objects like we used to be able to do for activities and fragments. So actually, this restriction helps to enforce a better app architecture where we only pass in the important bits like the IDs, for example, and then we load the data separately in the screen with a repository or use case. So the navigation component also support advanced use case like deep links and nested navigation graph. And the one big thing that's still missing right now is screen transitions. So there's currently no animation if you are using this Jetpack navigation library when we are navigating across different screens. However, they are working on it right now, and it is actually one of the highest priority feature that they are working on, and it is promised to be ready by the 1.0 version release of the library. Next is the favorite topic among Android developers, which is dependency injection. So Hilt is the recommended solution for dependency injection in Android apps, and it works seamlessly with Compose. If you're already using Hilt in your current app, then you are mostly good to go with not much changes required. You can easily retrieve a Hilt view model, annotated view model in your Compose. However, do note that the view model follows the scope of the activity of the fragment that is hosting the composable content. So if you are working on a pure Compose app, so you only have one single activity, right? So it is recommended to use the navigation component so that the view model can be scoped to the navigation graph or the nav backset entry. If not, your view models will be scoped to the single activity, which essentially means that you have the same single instance of each of your view model for the entire life of your app process, which is usually what you do not want. Another thing that works nice with Compose is the paging library. I think someone asked a question about that just now. So their paging Compose, the paging Compose library integrates with paging tree. And if you're already using paging with Recycler view, the transition to Compose and lazy column here should be very straightforward. Only the UI layer change. So the other things such as defining the paging source or the paging config, it remains the same, so we can reuse the same code. So it is also nice that the paging library exposes a flow for the stream of paging data. So it works nicely out of the box. And of course, we cannot miss out this important library called Companies. So it is not exactly a Jetpack library, but it is still maintained by Google. So it provides a collection of utilities and features that are not included in Compose out of the box, but it solves the very common problems that we face and we take for granted in the non-Compose world. So for example, image loading is definitely a core and important use case. But Android actually doesn't provide a solution for this out of the box. So I'm sure everyone here relies on using Glide or Picasso or things like that. And companies provide a Compose wrapper for some of these common image loading libraries, so we can easily use it in Compose. So it also provides some utilities for reacting to window insets, such as the status bar and the navigation bar, and also it also includes the keyboard insets as well. So which is introduced recently, right? So this allows us to build our apps with edge-to-edge UI. There's also some layouts such as view pages and flow layouts or swipe to refresh, which are not provided by the Compose team at the moment. However, these features are provided here in this library. And because they intentionally want to keep the API surface of the Compose smaller, so that they can focus on these the core APIs and achieve a stable 1.0 release faster. So the API of these features provided by companies, they are still evolving and they may be subject to changes as well. So it is likely to see them be included as part of Compose officially in the future. And when that happens, a company's features will become obsolete and will likely be deprecated. And we can just migrate to the official new solution in the future. So Jetpack Compose is still very new, and it has went through a long time in alpha, and only recently just went into beta. And many things have been changing. In fact, there's I think a lot of breaking changes when going through the alpha release. So given the state that it is in, the blog posts or answers you find online may not be up to date with the latest version. However, there's definitely enough content and resource for us to go in depth into Compose. So obviously the best place to look for more information on Compose is the official documentation. So I must say that the team at Google has been doing an outstanding job. So Compose is something new and totally requires a new way of thinking, but then they managed to break it down and explain the concepts clearly such that anyone can pick it up very easily. So the documentation here are always up to date and covers everything you need about Compose. For people who prefer watching videos over reading, they also provide many short videos covering many different topics and teaching you how to achieve the common use case of building an app. So there are also code labs which are very useful for those preferring the guided step-by-step learning. Although I also recommend creating a small project to play with Compose and to explore. To learn more, I think reading source code is also a very good way to learn. And I'm also always digging through the source whenever I'm trying to understand how something is being implemented, or I want to find out how what is actually going on under the hood. So it is a good thing that the source is freely available to us, and it is easy to navigate around using Android Studio. While going through the source, we may sometimes find references to samples on how to use the API. But as you can see here, sometimes they are all unresolved. However, not to worry, we can always find the unresolved samples in cs.android.com. So this is actually code search, right? So this is a very useful website, and be sure to bookmark it. So we can find everything composed or non-composed here, including the source and the sample codes. So I found it very helpful when learning Compose, especially with all the sample code on how to properly use their APIs. And if documentation and sample code is not enough, there's always the sample apps that we can refer to. So these sample apps are all open source, and it showcases the different techniques and approach to implement the various use case and effect that we want in our app. So it is definitely helpful that we can see how to combine all the different usage of the different APIs and libraries to achieve our desired goal. And it's always good to have a reference to learn from. And I think this is one of the most important resource when exploring Compose, which is the Kotlin Slack channel. So many interesting discussion takes place here, and we can always get insights directly from the people on the Compose team and the community. So I found it to be a very valuable unstructured source of documentation, if that's how to phrase it. And we can often get ideas and learn something new from people in the community doing and then see what they are doing with Compose. Interestingly, since Compose is quite new, there are many times where I Google search for a question in Compose, and I won't be able to find the answer anywhere else, but I'm able to find what I need from the Slack channel. So you can just type in your query in the Slack channel itself, and most probably you are able to find it. So if you can't find it, not to worry, you can simply ask your question there, and the friendly community or the Googlers will answer it for you. So do join the Slack community if you haven't already. And that's all I have today. So I hope you learned something new about Compose, and learning something new like that can be challenging. So I hope what I've shared today is useful for you and able to help you on your learning journey. So thank you. So now I'll be taking some questions if there are any. Things like how to handle different screen size in Compose. So as I mentioned, we can use local configuration to react to screen sizes, and it happens automatically. And if the screen size change, we can also the function will get recomposed automatically as well. So it is definitely much easier to handle different screen size in Compose than our traditional views that we are using right now. Will this recorded session be uploaded? Yes, I think it will be available on the Google Dev Space and the GDG Singapore channel. So if you want to catch it, feel free to catch up anything that you have missed from this tonight's session.